Welcome everyone to this demo. We will show how we have implemented the ISO 21111 Part 5 compliance test into a setup using an ECU of 5 GPOF ports. The oscilloscope, first you can see the real-time test mode 3 signal that consists in a square wave that we are using here to test all these optical transmission measurements, okay, that are reflected here. Okay, first we measure also the AEOP, that is the average optical power when you are on and when you are off. You can see here the square wave that we are using to compute all these parameters in the transmission side. And then we try to we compute also the harmonic distortion and the drop off, the positive and the negative drop off, also the jitter, and then the relative impulse noise. We have here a failure in red if it is everything okay, and in blue if it is computing right now this parameter. In this case, we are detecting, we are computing the relative impulse noise. Okay, then we have here the subtest that we will go through, and you can select the the subtest that you want to run. Okay, here in the subtest number 2, we are using, we are computing the consumption of our ECU. The ECU in our test is this one, that is a switch with 5 GPOF connectors, GPOF ports. Okay, and we are calculating the consumption of this ECU. Then in the second part, we are computing also the link time. That is the time that when both the reference and the ECU are up, and we have, a very low. We are talking about 50 milliseconds. And then we also calculate here in this graph, this is an histogram, okay? And we calculate in the second one the link time plus the wake up of the ECU under test. That's why, it's blinking here. So we have a little more time to do that. It's around 62 or something, 66 probably milliseconds with a, you know, you have a minimum and a maximum that is very close. So it's very useful when you are trying to control the latency of your system. Okay. Here in the last one, we are using, and this is another test case where both the reference and the ECU are completely asleep, and then you wake up the complete system and measure the time when you have the transmission complete, the link time complete. That you have seen that is very similar to the previous one. And this one, these are the subtests, the 3 and 4, when we are monitoring, the constellation inside the reception side in different points of the reception side. And this is the reference. The previous one was the ECU one, and also the impulse noise, the impulse response, sorry, the impulse channel response, okay, here. And also we have the frequency response that we have compute, okay. In the subtest number 5, we are taking, the setup like a black box, saying, well, we have two Ethernet inputs, and we calculate through 30 seconds is in this case, but you can change here the main, let's say, Ethernet parameters that you can measure. So you have the frames, the transmitter receive frames, the bit error ratio that you calculate, the packet loss, the the all the latency, the medium latency, the average of the latency, the minimum, the maximum, and so on. This is very important because the mean latency is only 22 microseconds, from one port to another that both are in the reference node. And then you go through one port in the switch, and then to the switch, and then to the other port of the switch, and then return. So we are talking about a very, very low latency for this ECU and with very low variation. Here in this one, we are taking the temperatures of the reference, and we are also taking the margin, the optical margin of each one of the links, the optical links. And we can see that we have more than 2 dBs that can be devoted to put more inline connectors. In this setup, we have 6 inline connectors if we take into account also the inline connector inside the POF switch and in the inline connector here. Okay, so we finish and we restart with the number one, and right now we don't have the red light here, and the new is because the new measurement is okay, and we have finished, all the testing. Thank you very much. Please contact us at luismanuel.torres@kdpof.com. Thank you very much for watching.